Almost done. We talked about this one. What is this? What is that? It's a lean misfire. Secondary ignition. Lean misfire. That's what they look like. Get used to it. To refer you back to a lesson that we did. I was just reviewing these last night. It was when we started on my Nissan, or the Honda case study. It's not even up on YouTube yet. It will be soon. The Honda that I got my butt kicked by, that was a lean misfire, and we identified it right at the end. That would be the lecture that's going to have this in it. So when I upload that, you'll be able to watch it. They'll review all the characteristics of the firing line and the spark line and why the spark line jumps up when there's no fuel in the cylinder, and just to leave it at that. Fuel is a conductor, and when there's no fuel there, that line's going to do that. Stuck closed fuel injector, we watched this the other day. No pintle hump. I have a pintle hump. Maltec 2s. This is the Maltec 2. They fixed the Maltec 1s. Maltec 2s will stick. An old TBI peak and hold. I just wanted to show that it is possible to see a sticking injector on this design. And I think this will be good for us for GDI systems coming up. And this one is firing. This one is stuck closed. Can you see the difference? I can't at this zoom level. I mean, I can because I know where I'm looking. Maybe you can if you look closely. The one to the right is good. The one to the left is bad. How's the amperage on both? So voltage conversion, 0.1. This is 1 amp. This is 2 amps. This is 3 amps. Looks like a 3 amp peak. Less than a 1 amp hold. I'm okay with that. Voltage waveform looks pretty good. Spike's not quite hitting 60, but I bet we zoom in on that. There's a clip off at the top from a Zener dump. You know what's cool is I can say that and you guys kind of know what I'm talking about. Where are you looking at? The blue trace or red trace? Blue trace. You're looking right here and you're looking right here. That's exactly where you should be looking. Let's zoom in on it, right? This is where we need to know how to use our scope a little bit. Let's zoom in on the, well, we'll zoom in on this section first. Can we see the turn on in here? We can. Very, very subtle, isn't it? Okay? And there is a Zener dump here, isn't there? How about that one? That's the tail end you were just looking at, Billy. Really tough to see still, but there is a difference. This is the same. Look, this is just an old TBI system I had sitting on a bench. That, you know, the injectors stick. When you get an engine, this is a lesson to you guys. You get an engine out of a junkyard that's been sitting for a long time, those pintles will stick closed. Varnish builds up, that gasoline all vaporizes off, and it just cakes that pintle on there, and that's what was going on with this. And I could smack it and make it work temporarily, and then when it would sit again, it would stick again. It was a computer setup I had on a table. We gutted a car, and I pulled the computer out and the throttle body, and I built a computer system on the bench. That's where I got this. I just wanted to see if I could really see the pintle humps in these. And you'll read a lot of info on these pintle humps, and it'll tell you in some of the books that the pintle hump should be 60% of the ramp, and that's crap, okay? They can be anywhere. And what you want to do is you'd want to compare them cylinder to cylinder. And then there's a warning here too. Watch my Nissan Maxima video that I've been talking about. Newer video, 2-part series I just uploaded last term. We replaced an injector and the pintle hump was in a different location than all the other ones. Why? Because it was an aftermarket injector. And so the hump was in a different location. Think about that down the road. If that car ever comes back with a misfire and you're focused on that pintle hump in the location on that one cylinder, isn't that going to raise a red flag? Yeah, forget about where the location is. It's variable, and if you change the injectors, it's like that too. There are times we can use it though. In a case like this, I mean, it's on a Ford Taurus. This was Jeff Kaplan's car back in the day, and I see a clear difference in these humps. suggesting something mechanical is going on with this injector. The waveform looks good, good battery voltage, good ground, good spike, not quite 60, but there's a Zener dump there. Known good cylinder, looks pretty good. Look at that pintle hump. I've never seen anything like that. This is the bad one, the misfiring cylinder. It was easy when he brought it in. He already swapped coils, he already swapped plugs, the misfire stayed with the number 5, so when he brought it back in, I was focused on the injector the whole time. I mean, we did compression, I think it was good. Here's what we did though with this. We followed this up with an injector balance test. If this is truly a mechanical issue and the plunger or pintle is sticking, we should see it with a balance test, and we did it. And what we found, I have some small print here, hard to see it. We had a 22 PSI drop on this cylinder, this one that has these crappy patterns. And we had a 28 PSI drop on all the other cylinders that had that pattern, showing us that there was not enough flow taking place from this number 5, and that we actually were able to see a sticking pintle hump that showed us a flow problem. Now, typically that's not the case. If you want to see a flow problem on a fuel injector, you're going to have to do a balance test or put some type of electrical transducer in the fuel rail and measure the impulses of the pressure when the injectors fire. This is something that can be done too. I don't have any of those examples, but I guess we could talk about it. I'll see what we have left. I think that's the end of this. Oh no, the last page is this balance test, and I have enough videos for this. So you know what? Watch the videos. We already watched them, and I want to change this. I know I have that number. What should they be? And I mentioned this to you guys already. What should they be? Equal. They should be equal. There should not be any difference. I've done enough of these where I thought I had an injector problem. They should be the same across the board. I know they're giving you, the manufacturers give you some tolerance, but when you see enough of these and the good ones are all the same, then why would I want to have a tolerance? I wouldn't. They should be the same. One last thing I want to share with you guys, and I have it in which video? I have a video where I show, all right, a flow issue should be added to this. And it was on, the Pontiac Vibe is the one that I showed you guys the balance test on, right? That might be this one. I wonder if that's it. There was a 2-part series on that Pontiac Vibe. So I'll just write that. It's a Pontiac Vibe, which I said was a Toyota engine. Toyota engine. That Pontiac Vibe, Toyota engine. On that system, I show you another way to do a balance test. And what I did is I took, let me end this, get a picture of my fuel delivery. I took the pressure regulator, see if this makes sense. I took the vacuum hose off the regulator and I put a hose on top of this, and I used a pressure transducer that makes an electrical signal with pressure, and I fed that into my scope. And what I was watching was diaphragm deflections. So as this injector would spray, the diaphragm would move according to the spray of this injector. Because that injector sprays, there's a pressure loss, diaphragm closes. When that injector shuts off, I'll get a deflection again in the diaphragm. In other words, a pressure change in the upper chamber will occur. Fire this injector. I'm laughing because that last statement just sounded like I was a professor for something completely different and not cars. Do you know what I mean? It's just a mechanic. I'm just a mechanic, and this is cool to me that I can see pressure changes up here that would be equal to the flow rate from the injectors. And what I showed in that video is we confirmed, if you remember, we confirmed that one, I think it was the number 4 injector, was really, really the worst out of the bunch. And I showed that we could see it from the regulator with a pressure transducer on the scope. So I can see like diaphragm deflections, and say a good one would look like that, and then the one cylinder that was weak, it looked like that. And then I proved it by unplugging an injector and forcing a nose spray, and what we saw was something like this in the picture. And then what you can do is you can sync that pattern with the injectors to know which one it is. So if I'm seeing 4 events, which one's which? I don't know. Which one is this? Well, you just take your voltage trace, your second channel, grab the control wire, feed that into your scope, and then the same time we see this crap going on would be the same time we would see one of the injectors firing, and so your pattern, maybe the second channel would come in underneath, and let's get rid of this. Here's maybe what your second channel looks like. Not exactly that, but it wouldn't be exactly timed right there, but we would know when that injector is firing is when we're going to have a pressure change. It would actually be a pressure drop, not a pressure rise, but you get the idea. And so we can synchronize with that and figure out, now I know what you're thinking. What are you talking about? Why would I want to do that?
I can answer.
It was a rhetorical question. The reason we want to do this and develop this is our newer systems. They don't have ways that we can do this balance test. Or maybe the injectors are covering, you're under the manifold. So you'd have to remove the manifold to do a balance test. There's ways around that too. I actually show a video on doing a balance test where the injectors are under the manifold, accessing the bulk connector and doing it there. We can do that. There's times where we're going to need this test. On that Honda that I mentioned to you guys early in the term, I tried to do it and I couldn't access on that Honda the tool that I used that same pressure transducer and I couldn't get a signal off of it. Didn't work. So I did attempt this because I had it work for me before and it was on that Vibe, but on the Honda I couldn't get a reading from it. So I have a suggestion for you guys for this transducer. It won't cost you anything. Just the next time you get a GM, hang on, let me stop talking for a second, get the picture up. Next time you get a GM fuel tank pressure sensor. You guys saw one on that car we did the fuel pump on this term. There's a pressure sensor that sat right in the top of the tank. The reason we want to use one of these is very low pressure changes cause large voltage changes. So grab that sensor, take it out of there, and what I did is I wired in, I used to have that number. I wired in a resistor so I could go directly to battery voltage and drop this down to 5 volts. So basically what I'm doing is taking this, I should have this number for you. This is going to 12 volts, right to battery voltage. This one's going right to battery negative, okay? Battery positive, battery negative. I'm using a resistor in series to the reference. This would normally be a 5 volt reference wire, but I put the resistor in there to drop the voltage down. And then what I'm doing is this signal wire isn't going anywhere. I'm just using that to feed my scope. And then what I'm doing is I'm using this tube, that's the vacuum hose, and I'm putting that on top of my fuel pressure regulator. And now I can see those deflections I'm talking about with a makeshift fuel tank pressure sensor. Does that make sense? I mean, I did it and it works. I did it on a Honda. Let's see if I can find the waveform. That's what I use. So it won't cost you anything. I mean, if you have a scope already, you now have the ability to do this without buying a real expensive pressure transducer. This is just showing, this was the same car. I don't know why my amp probe's in there. What am I doing? Oh, that was what I used to synchronize it. So I used the amp probe on an injector instead of a voltage waveform. I'm using the amp probe to synchronize the pattern. And so there's my pressure regulator where that's going to my makeshift transducer, my fuel tank pressure sensor. And then taking my amp probe around one of the injector control wires to synchronize that. And I know this was on a Honda. Hang on. I gotta find this picture. That is a snap-on though, isn't it? So my guess, that's a snap-on amp probe. My guess is I was using one of our snap-on tools. So let's go to my ShopStream files. And yeah, right. Injector flow. First try. First try. How about that? There was a known good car. There was nothing wrong with the car. We were just doing some experimentation to see if we could do this. The yellow trace is the diaphragm deflections when the injectors fire. The yellow trace is coming from that guy right there. Okay? Yellow trace is that. What's the green trace? Well, I need to know what the yellow trace is. I need to know which cylinder's which, right? And what we could see with the green trace here is we can see some repetition, which makes me happy. Like this is that injector that I have the amp probe on, and this is that same injector right there. Does that make sense? And then if we did it right, and if this yellow trace truly is the diaphragm deflections, then I would see 4 of them in between my events. That's exactly what I see. Here's the cool thing too, is we're looking at current, right? So this is the beginning of the spray, and that's the end of the spray. Would it make sense that the deflections in the diaphragm would occur just after that? Because these are mechanical changes now compared to electrical changes, and they're always delayed. All right, so then what I decided to do in the next picture is I decided to create a flow problem by unplugging one of the injectors. Okay, so next capture is that. And here's the event where I unplugged one of the fuel injectors. There's my sink. There's my sink. I see 1, 2, 3. In here, I am missing 1. Now, what's the other stuff in there? You have to remember the fuel pump's running, and the regulator is going to also deflect from the fuel pump pulsing into that rail too. So, right? I mean, it's not perfect, but is that something that we can develop and use? Okay, now, is that first, before I give you the alternate, any questions on what I did there? Save your next GM fuel tank pressure sensor. Okay? That's part of my arsenal I have in my toolbox, is that GM fuel tank pressure sensor. The reason we use that, not a map sensor, because they're calibrated differently. It takes a lot more pressure change to change the voltage on a map sensor than it does that GM tank pressure sensor, because tank pressure doesn't change that much. Not compared to vacuum and atmospheric pressure on a map sensor. Okay? Pretty cool, right? I don't remember. I read that. Someone at IATN was talking about building one, and that's what they made. And I'm like, oh, that's a great idea. I'm going to have to try it. The only thing I wish I could tell you guys right now, what is that resistor? You know what I did? I just experimented with it. I have a whole box full of different resistors, and I just found a resistor that when I plugged it in, this is key though because of current flow. This will make sense to you guys that for me to pick the right resistor, I was measuring voltage. I was measuring voltage here and here when I had this plugged in, which is really important that that's plugged in because I need to have current flow to have a voltage drop across this resistor. If you were to experiment and use different resistors here and you had this unplugged, this would be 12 here all the time, regardless of what resistor you picked, because there's no voltage drop across that resistor until you plug it in. So when I was experimenting, plugged in and I started adding resistors to where I had somewhere around 5 volts. And here's the thing, it doesn't matter if it's not exactly 5. We're not using this, nowhere in this procedure are we using the number to tell us anything. It was more of the waveform itself, right? I didn't look at this yellow trace and say, well, this one's 1.5 volts here and 2 volts here. No, it's just a comparison of them all. So I didn't really care. What if you have 4.6 volts for a reference and it's supposed to be 5? Who cares? We're just looking for changes in the signal. So I apologize, I don't have that ohm number written down for that resistor. I'm telling you guys to experiment with it. Not somewhere in 1,000 ohms or something like that comes to mind. Somewhere in that range. These are pennies at Radio Shack. Questions on this procedure, on what I just showed you. It's an alternate injector balance test. It is cool. All right, so now some of you are thinking, maybe, well, the regulator is in the tank on most of today's cars. You would be correct. So guess what? Can't use this test. But what we can do, and I haven't done this yet, I want to. We'll have to play around with it. What I would like to do, and I've read about doing it, it would be the same thing, would be, okay, the regulator's in the tank, no big deal. Let's put a pressure transducer. Now you have to buy one. Now we can't use our cheap one. Let's put a pressure transducer in the rail, and let's do our checks the same way we were on the regulator. The difference is we're not looking at diaphragm deflections. We would be looking at pressure changes when the injectors fire and do the same thing. Does that make sense? So I have the ability to do it. I just haven't done it yet. And I think there's going to be times where this would help us. You know, it probably is one of those tests, though, that will fall at the bottom of the list because a lot of our systems don't give us Schrader valves. So just to do the test itself, you would have to tee in your pressure transducer, and you're going to work hard to do that. Do you know what I mean? And that's really why I haven't done this one. Thinking back to my Honda, I used a pressure transducer like I did in the Pontiac Vibe that I want you guys to watch. I used a pressure transducer. It was actually a PV350. It was made by Fluke. PV350 is the one I used. And I couldn't get any reading from here. Now that I'm talking with you guys about my makeshift sensor, I should have used that one because it was probably much more sensitive than that Fluke PV350 pressure transducer. I should have tried it. On that Honda, I was desperate. And I think that's maybe where we are. I'm just giving you another tool to throw in your toolbox, that's all. You can't have too many tools. Do you know what I mean? You can't have too many. There's that one job where you need that one tool, and that is the one that will, separate you from 2 more hours of struggling or finding the problem right now. This is maybe in that category. We good? That's pretty much everything I got for you for section 18. So are there some notes maybe we can add to page 27? Pontiac Vibe, watch that. A note here would be a GM, sorry, my ink is being uncooperative. Hold on a second. Try that again. So watch the Pontiac Vibe videos. Watch those and get yourself a GM, man, it's still messing up, a GM fuel tank pressure. Get yourself a GM fuel tank pressure sensor. Next time you change one of them GM pumps, they just get pitched anyway. It all comes with a new pump. Take it. Put it in your toolbox. Okay? And this would be where do we put this thing? We put this, install it where? Install on the vacuum hose to the regulator, right? Watch your diaphragm deflections. Okay? What if you don't have a regulator? No regulator? Use a pressure transducer on the rail and pretty much do the same thing. And how do we sync it? How do we sync these? Injector volts or injector current would be your sync probe. How do you synchronize the patterns? And this is for both of them. I'm not going to write it because I'm really struggling with this ink. It's not allowing me to do this right now. I could write it out for you separately if you want on a different page, so you have it, or you can know that this is recording and you can watch it, so the notes are good enough that you have. Synchronize it by using injector current or injector voltage on a single cylinder. We don't want to look at current for all of them. Single cylinder. Cool? And I think maybe what I'll do down the road is I'll add a page on that. I'll kind of format it, put some pictures and, down the road. Any other questions? We good? All right, so we're done with the injection. Going to ignition systems next.